Okay, today we're going to start Unit 4. Unit 4 is all about quadratic functions and equations. So we're going to be spending a lot of time talking about quadratics. But today, before we actually get to some quadratics, we're going to do a little bit of build up to get there. So we're going to do Lesson 1, and we have two learning objectives or I can statements. I can factor out the GCF, and I can factor by grouping. So as we take notes, I expect a couple things from you. You should have a notebook of some sort, preferably a composition notebook, so you can use that when we return to in-person. But you should have a composition notebook, and you should take notes as I give them. So I expect you to write down what I'm asking you to write down. Write down the vocabulary, examples, steps, try the examples on your own and see what you can do. The notes will be helpful. I'm showing you exactly how to do the problems in your Math Excel work. So if you try the examples on your own, it will help you when it comes time to do those assignments. Okay, now, giving notes to an empty classroom and recording them is different than giving live instruction. If we're live or in person, I can tailor my speed to you. If you need me to go faster or slower, I can do that. I can ask questions. We can talk back and forth, have some really good discussion. But it doesn't work that well for virtual learning or for the recorded lessons. Okay, with the recorded lessons, you hear the bells. Sometimes there are announcements or interruptions, and I just have to pause and go on. So if you notice a weird pause or something like that, it's because something's come up and I'm having to pause my recording. So it's just different. I'm going to be going faster in the video than I would in person. So just remember, this is a video and you can pause and rewind as you need to. So if you need to watch something again, you're welcome to do so. If you need to pause and catch up to me, do it. Okay, you're free to do as you need, kind of at your own pace. So keep that in mind as we go through here. When I ask you to write down something, please do it. If I give you time or ask you to pause and try some examples, please do that. It will be helpful and beneficial to you. I do ask you to write down the learning objectives or the I can statements just because I think it's really important that you know what we're doing. You need to know what you're learning. You need to know what the goal of the lesson is. So I ask that you write those down. When we return to in-person and we do and everything's kind of back to normal, hopefully, and we'll do some notebook checks, and that's something that I'll look for. I'll look for those I can statements. So just getting a habit, writing them down so you know what you're learning. At the end, I will give you a reminder to go to your Math Excel work, but if you go through the video, you take the notes, you do the examples, and you're still feeling stuck and you feel like you need some help, you need more examples, you need me to talk through something with you one-on-one, I'm happy to do that with you. You are welcome to jump back in the Google Meet if it's during class time, or if it's not during class time, send me an email, or you can wait until the next class period, the next Google Meet, and you can ask me there or hang back and ask me, and I would be happy to go over anything that you need me to. Okay, so with that being said, let's get started in Lesson 1. Okay, we're going to start with just a little review. So probably back in Algebra 1, and then we might have even talked about it first trimester. I can't remember. But we have the FOIL method. So the FOIL method is when you have a binomial times a binomial. That means you have two terms and two terms. So you use first, outer, inner, last to multiply these two quantities together. Okay, so you might remember doing that. If you were in my class in Algebra 1, we also looked at the box method and we treated it kind of like a Punnett square, and you had that option. So whatever you use, we're going to think of it a little bit differently today. We're going to think of it as repeated or double distribution. So it's like the distributive property happening twice. Okay, so let's see what that looks like here. All right, so I'm going to take this 3x and I'm going to distribute it to the second quantity. So that's like doing 3x times the quantity 2x plus 3. Okay, and then I'm going to take, let me get a different color. So sorry. All right, so then I'm going to take 4 and I'm going to distribute it to both sides, both of the other quantities. So that's like plus 4 times the quantity 2x plus 3. All right, so this is going to look really familiar. We're going to see something that looks like this again later, okay? So if you want to make a little note, we'll see this later, okay? So what we did is we took this first quantity, multiplied it, or this first term multiplied it by the second quantity, second term multiplied it by that quantity, and now we can simplify. So 3x times 2x is 6x squared. Remember, an x times an x is an x squared. 3x times 3 is 9x. 4 times 2x is 8x. 4 times 3 is 12. Then you can see we have like terms in the middle. So we're left with 6x squared plus 17x plus 12. Okay, so it's a multiplication there. All right, so we're not going to focus on this too much, but I wanted you to review that and think of it as the double distributive property or repeated distribution, whatever you want to call it. And then we're going to kind of go backwards. So factoring, which is what we're starting. We're doing 2 different types of factoring today. But factoring is the opposite of what we just did here. Here we put 2 factors together, okay, and got this polynomial. We're going to go backwards. So we're going to start with the polynomial and we're going to break it up into pieces, okay? Next, we're going to look at some vocabulary. We have a quadratic expression. Quadratic expression is just this, ax squared plus bx plus c, where a cannot be 0. If a is 0, then it's no longer quadratic because this term would be gone. Remember, expressions do not have equal signs, okay? There's no equal sign there. And you can't solve them. If we're given an expression, we cannot solve it. You cannot solve unless there is an equal sign. Okay, next we have factoring. Factoring is to rewrite an expression as the product of factors. So 20 is an expression. 2 factors of 20 are 2 and 10. So we factor 20 by changing it to 2 times 10. The same is true with this quadratic expression. This quadratic expression, here are 2 factors, and we've written them together with multiplication. So we can factor 20, we can factor a quadratic expression. It's that same idea because this times this equals that, just like 2 times 10 equals 20. Okay, our next definition is factor. A factor is just a quantity that goes into another quantity evenly. Just like we said, 20 can be broken up into 2 and 10. Well, 2 is a factor of 20. 10 is a factor of 20. The same thing here. We can multiply these 2 binomials to get this quadratic expression. So x plus 2 is a factor of this quadratic. Okay? You're often going to see the phrase factor completely. When you see that it says factor completely, that means we're going to break it apart as much as possible. So we're going to break it down into as many factors as we can. Just like we did here. We broke 20 down to 2 and 10. We could break that down even farther. We could change 10 to 2 and 5, and that would be factor completely. Okay? We're just going to do that with polynomials. Okay, and I might have lied just a second ago. Our last definition is GCF. GCF stands for greatest common factor, and so that's the largest quantity that goes into another quantity evenly. So we're going to talk about greatest common factors more in just a little bit, but you do need to know what GCF stands for. Also, as we're factoring, you're always going to check for a greatest common factor first. So make a little note there. Always check for the greatest common factor. Now, we're going to switch gears a little bit, and we're going to work through some examples of factoring out the GCF. So if you need to, pause, take a minute, make sure you get all the vocabulary written down, and get ready to go. Okay, so let's look at some given quantities. So if you're given 5 and 20, what's the GCF of 5 and 20? What's the largest number that goes into both of those evenly? Okay, well, the answer is 5. 5 goes into 5 once and goes into 20 4 times. What about 12 and 18? What's a number that goes into both of those? Okay, 2 goes into both, but is that the largest number? No. 3 goes into both, but that's not the largest either. What's a bigger number that goes into 12 and 18? 6. Okay, variables. If I have x squared and x to the fourth, that means I have 2 x's here and 4 here. How many can they have in common? They can have 2. So it's the lowest exponent. Okay, here we have xy squared and x cubed y to the fourth. So how many x's do they have in common? This one has 1, this has 3. So the most they can have in common is 1x. All right, and the y's, we have 2 here and 4 here. What is the smallest amount of y, or the largest amount of y's that they have in common? It's 2. Okay, so for your numbers, you find the largest number that goes into both or all of them evenly. Okay, for variables, it's going to be that smaller exponent, because if I have 3 dogs and you have 5 dogs, the most dogs that we can have in common is 3, because that's the most that I have. And so the same thing works with the variables. Okay, so now we're given some expressions, and we're going to factor out the GCF of each one. Okay, so we're going to look at the numbers and the variables. And there's a couple different ways we can do this. Some of you that are really good at multiplication, you're going to be able to see it right off the bat. But I'll show you another way to get the answers if you're unsure. So we need to look at the numbers and the variables. So we have 6 and 9, so we need to find the GCF of 6 and 9. And then we have our variables, x squared and xy. And we'll need to find the GCF of those. Okay, so here's one option. You can list out all the factors for each term and then find pairs. So those of you that had me last trimester, or some of the other teachers, we had some time to rewrite radicals, simplify square roots. And so we practiced writing out factors and making factor trees. So it's the same kind of idea here. So if you have 6x squared, that's the same as 2 times 3 times x times x. And if you have 9xy, that's the same as 3 times x times y. So you can look for pairs, and that'll help you find the GCF. So here's a pair of 3's, and here's a pair of x's. That means that 3x is the greatest common factor. So I'm going to write that out front. So 3x. All right. So the greatest common factor of 6 and 9 is 3. And then here we have an x squared and here we have an xy. So x is what they have in common there. You can't do x squared because this one only has 1. And you can't bring out a y because y is only in one part of the expression. So the GCF is 3x. And then in parentheses, we're going to put what's left over. So from this term is 2x. And then on the bottom is 3y, so plus 3y. Now, you can think of that a couple different ways. If you don't like looking at it this way, you can just do some division. 6 minus 3 is 2. If you have x squared and take out one of the x's, you have 1x left. And then positive 9 divided by 3 is 3. You had an x, but you took it out, so there's not any. You have a y, didn't take it out, so the y is left. And so that's what we're doing. And like I said, you can do it a couple different ways. You can write it all out. You can just think, what's the GCF of 6 and 9? It's 3. How many x's do they have in common? Do they have any y's? And then you can do division to get what's left over. Okay, so either way works for me, whatever's easiest and quickest for you. All right, so number 2, we have 49x squared minus 14x. So we have 49 and 14. A number that comes to me pretty quickly is 7. I know that 7 can go into both of those evenly. Here we have an x squared and here we have an x. So if there's 2 and 1, how many can we pull out? 1. Okay. Now we can do some division to get the leftovers. 49 divided by 7 is 7. If you have 2 x's and you divide 1 out, you have 1 left. Negative 14 divided by 7 is negative 2. If you have an x and take out an x, are there any left? No. So that is your answer. However, if you weren't sure about that and you wanted to list it out, you could. 7 times x, negative 2 times 7 times x. You can pair up a 7 and pair up an x, so that's what went out front. and then you had a 7x on top and a -2 on the bottom. Okay, so like I said, either way works for me, whichever is easiest for you. Okay, so let's do a couple more examples. If we look at this next expression, we have a -4, a -10, and an 8. If your front coefficient is negative, then that means there's going to be a negative in your GCF. Go ahead and pull that out. If your leading coefficient, the number in front, is negative, your GCF is negative. So what's the biggest number that can go into 4, 10, and 8? 2. Now, do all three terms have an x? Yes. So we have 4, 2, and 1. So how many can I pull out in the GCF? 1. All right, let's see what's going to be left over. -4 divided by -2 is 2. If we have 4 x's and we take out 1, how many are left? 3. -10 divided by -2 is 5. I have x squared. I take out an x, so I have 1 left. And then 8 divided by -2 is -4. I had an x, but I took it out, so I don't have any. Okay? If you wanted to, you could list out the factors just like we did up here. You'll just have 3 lines of them, and that's fine. It works the same way. And I forgot to mention, you can check your answers by doing the distributive property. Okay? So if you want to check your answers, go back. -2 times 2 is -4. X times x cubed is x to the 4th. -2x times 5x is -10x squared, and so on. Okay? Now, pause the video and give number 4 a try. Okay, let's see what you got. So we have 24, 18, and 36. So I know 12 goes into 24. That's a pretty big number. And it goes into 36, but does 12 go into 18? No. I know 18 goes into 36, but it doesn't go into 24, so I'm going to have to go a little bit lower. I know a 2 works, but 2 is pretty small. What's another number that can go into 24? What about 6? Okay, 6 goes into all 3 of those numbers evenly. Now let's look at our x's. We have 3, 2, and 1. I can pull out 1. What about my y's? I have 2, 1, and 3. I can pull out 1. And now we can see what we have left over. 24 divided by 6 is 4. I took one of the x's out, so I still have 2. I took one of the y's, so I still have a y. 18 divided by 6 is 3. I had 2x squared. I took out 1, so I have 1 left. I had 1 y. I took out 1 y, so there's no y's left in that one. And then 36 divided by 6 is 6. X, I took it out. I have 3 y's. I took out 1, so I have 2 left. Okay? Okay, our last example, we're going to look at it a little bit different. So we have 3x squared y plus 2y. So look at your numbers. We have 3 and 2. Are 3 and 2, what's the GCF of 3 and 2? It's just a 1. So we could pull out a 1 there if you want to, if that helps you. And then both of them don't have an x, so we can't use x's, but what about y's? They have 1 y in common. Okay, now that's the same as just y. If you want to pull out the 1, you can. You will have to sometimes. If there's nothing else, you might have to pull out a 1 when we're factoring by grouping. But for now, that's just a y. Okay, and what do we have left? 3x squared plus 2. Okay, so that's pretty easy. We saw that they have a y in common. We pulled that out front and put the leftovers in parentheses. Now, we can do the same thing when it's a little more complicated. So if I was to give you 3x squared times x plus 1 plus 2 times the quantity x plus 1, that is the same thing as this. We've just replaced y with something else. Do you see that? These are the exact same, just your y is no longer y. Okay? So if on this problem we pulled out the y, on this one, what do they have in common? An x plus 1. So we can pull out that GCF, that x plus 1 is the greatest common factor Okay, it's a GCF. And then we put what's left over in the parentheses. So we put x plus 1 as the GCF, and then we have 3x squared plus 2 left over. And so that's the same thing. It works the exact same way. Okay, and this is what we're going to have to do when we're factoring by grouping. After we do the GCFs the first time, you're going to end up with something like this, and you're going to have to pull out that GCF, which is now a whole quantity in parentheses, and then you'll put your leftovers to make a separate quantity. Okay, and you actually have some problems in Math Excel where your problem looks like this, and you just have to do this last little step. Okay, the second half of the lesson, and your second I can statement or learning target, is I can factor by grouping. So to factor by grouping, we're going to use what we just did factoring out the GCF. So we did some examples of that, and we're moving on because you're still going to practice that in factoring by grouping. So here are some steps that you can follow. First, check for the GCF of the whole expression. Look to see if there's a greatest common factor that you can pull out of all the terms. Then you're going to split the expression in half. Okay, you'll have 4 terms. You're going to split it in 2 and 2. You're going to factor the GCF out of each half. Then step number 4, you're going to look at what you're left with and factor out the remaining GCF. And so I drew a little arrow. Step number 4 is going to look like what we did here. Okay, so it would be beneficial to make sure you have that written down. Then last, you can check your answers using the FOIL method or repeated distribution, whatever you want to call it, or the double distributive property, whatever works for you. Okay, and we'll work out some examples so you can see what I mean. Okay, the first thing I'm going to do is look at my expression. I have x cubed plus 9x squared plus 9x plus 81. And I'm going to check for a GCF. So I have a 1, 9, 9, and 81. It's tempting for me to want to pull out a 9, but I can't because this is just a 1. So I can't pull out any numbers. And so now I'm looking at the variables. I have x cubed, x squared, x, and no x. So all of my terms do not have an x, so I can't pull anything out. So there's no GCF here, and I can skip to step number 2. Split the expression in half. Okay, I'm just going to split it right down the middle. I'm going to look at the first half. In step 3, factor the GCF out of each half. So I'm going to do that here. So I have 1 and 9, just a 1. X cubed and x squared, the GCF is x squared. Okay, now let's get our leftovers in parentheses. If I have 3 and I take out 2, there's 1 left. If I have 9x squared and I just take out the x squared, I'm left with a 9. Okay? Now, let's do the same thing with the other half. So 9x and 81. This time I have 9 and 81. What's the GCF of 9 and 81? 9, and it's positive. Okay? They don't share an x, so I can just leave a 9. So 9x divided by 9 is x. 81 divided by 9 is 9. Now, if I've done everything correctly, what's in parentheses here should match. Okay? So here I've got an x plus 9 on both. Okay? So that means I'm in the right track. Step number 4, look at what you have left and factor out the GCF. So now that I'm looking at what's left over, what do both sides have in common? That x plus 9. So I'm going to pull the x plus 9 out as the GCF, and I'm going to put the leftovers in parentheses. So I have x squared plus 9. And that is my final factored answer. Or I could have written it the other way. I could have written x squared plus 9 in the first one and x plus 9 in the second one. It doesn't matter what order as long as you have the parts correct or the factors correct. So we factored this expression completely. Okay? And I can check my answers using the FOIL method or repeated distribution. So x squared times x is x cubed. X squared times 9 is 9x squared. 9 times x is 9x. And 9 times 9 is 81. Okay? You can check your answers and make sure you have them correct before you submit them. Okay, here's number 2. 30x to the 4th minus 25x to the 3rd plus 60x squared minus 50x. Step 1, check for a GCF of the whole expression. So I have 30, 25, 60, and 50. What's a number that can go into each of those evenly? 5. Okay, now does every term have an x? Yes. So we have 4, 3, 2, and 1. How many can I pull out? 1. Okay, so that's step number 1. Check for a GCF. And now I need my leftovers in parentheses. So 30 divided by 5 is 6. I have x to the 4th, and I take out 1. I have negative 25 divided by 5 is negative 5, and I have 2 x's left. 60 divided by 5 is 12. I had x squared. I took out 1. I have x. Negative 50 divided by 5 is negative 10, and I've left the x. Okay, so this one's a little bit different. So we have our GCF, but then we have this other expression that we're going to have to split in half. So I'm going to split this one in half, and I'm going to look for the GCF of 6x cubed and 5x squared. So 6 and 5, that's just 1, but they do have some x's, so I can pull out x squared. That leaves me with 6x minus 5. Okay. On the other side, I have 12x and 10, so I can pull out a 2, and that leaves me with 6x minus 5. And what do you notice about what's in parentheses? Those are the same. They're a common factor. That's good. That means I'm doing things correctly. I'm going to bring this 5x just down in front. Okay, that's my GCF from earlier. And I'm going to bring it all the way down to my final answer. Okay? All right. And so now my common factor here is 6x minus 5. So I'm going to bring that out. And then I'm going to put my leftovers in the second set. So that's x squared plus 2. Now, if I were to do the distributive property and then the FOIL method, all this would work out to give me our original expression. And that's our final answer. Okay, here are examples 3 and 4. If you're feeling comfortable, you feel like you know what you're doing, you're welcome to pause the video and give these a try on your own and come back and check your answers. If not, you can stick with me. So number 3, I have 18, 14, 9, and 7. None of those have a greatest common factor other than 1. All of my terms don't have an x, so I can't pull out a GCF for the whole thing. So I'm going to go straight to splitting it in half. So I have 18x cubed and 14x squared. So I know a 2 can go into 18 and 14. I don't think there's anything larger. I can pull out x squared. And so 18 divided by 2 is 9. X cubed, take out x squared is x. Negative 14x squared divided by 2x squared is negative 7. Now, what you might notice is that this quantity is the same as this quantity. Okay? When that happens, you know that you need to pull out a 1. Okay? And when we're factoring by grouping, you have to pull out some kind of greatest common factor. So 9x and negative 7, nothing else can be pulled out of those except a 1. So we have to bring out a 1, and then you can just bring down that quantity. But since you've already noticed those are going to be the same, those are the same, you know that's going to be your GCF that you're going to bring out for the end. So we have 9x minus 7, and then we have 2x squared plus 1. All right. Number 4 is similar. 8, 5, 16, and 10, there's not really a GCF we can pull out. All of the terms don't have an x, so we're not going to have a GCF of the whole entire thing, so we can go straight to splitting it in half. So 8 and 5 is 1. X cubed and x squared is x squared. Okay, so I'm going to be left with 8x plus 5. And on this one, you notice both terms are negative. You don't have a negative here, so that means you're going to have to pull out a negative or factor out a negative. So 16 and 10 is 2. So 16x divided by negative 2 is 8x. Negative 10 divided by negative 2 is positive 5. Your common factor is now 8x plus 5. And your leftovers are x squared minus 2. Okay, example number 5 is going to work out a little bit differently, but we're going to approach it just like any other. We have 2, 3, 4, and 8. We can't pull out anything other than a 1. All of the terms don't have an x, so we can't pull that out. So we're just going to start by splitting it in half. We have 2x cubed and 3x squared, so that would be 1x squared for our GCF. And that leaves us with 2x plus 3. And on the other side, we have 4x plus 8. So my GCF is 4, so I have positive 4. That gives me x plus 2. What do we notice here? Do we have a GCF? Do those quantities in parentheses match? No. So we would say that this one is not factorable, not possible, or sometimes you'll hear it referred to as prime. So I think in Math Excel, I think it says the expression is not factorable. So I think that's what you would choose in Math Excel, okay? But you could see one of those occasionally. Watch out for them in your Math Excel work. Now, our last two examples are a little bit different. You're going to factor this by grouping, but it doesn't look like the other problems. All the other ones have had 4 terms, so we just split it in half. Here, we're only given 3 terms, so we have to turn it into 4. So this is what we're going to do. You're going to make a little star, or a little X, okay? In the top, you're going to do A times C. So here we have 3 times 5, and that's 15. In the bottom is your B, or in this case, 8. So we need 2 numbers that multiply to give us 15 and add to give us 8. That's pretty easy to see. It's 3 and 5. So we're going to turn this expression into 3x squared plus 3x plus 5x plus 5. So we've turned this into an expression with 4 terms. Now we can factor by grouping. So on the first side, we have 3x. So that leaves us with x plus 1. And then over here, we have positive 5, and that leaves us with x plus 1. Now our GCF is x plus 1. And we're left with 3x plus 5 in the other quantity. Okay? So if you're given an expression or quadratic expression with just 3 terms, you can factor it by grouping. And some of you actually might think that's easier than factoring how we're going to in our next lesson. Okay? But the key is you do have to make this little star and figure out your 2 inside terms. Okay, here's one more example. It's like number 6. You're just given 3 terms, but we need to turn it into 4. So we can make the x, okay? In the top, we're going to do A times C. So 1 times 56 is just 56. Bottom, we're going to put B, which is our 18. So we need 2 numbers that multiply to give us 56, but they add to give us 18. Okay? So you can go down some different factors of 56. You can do 2, 3, 4, 5, 6. You can divide by each of those until you find a pair that works. So I believe when you do 56 divided by 4, you get 4 times 14, and that does in fact give you 18 when you add. So 4 times 14 is 56. 4 plus 14 is 18. So I'm going to change this expression to x squared plus 4x plus 14x plus 56. Okay, now I can factor it by grouping. So out of the first half, I can bring out an x, so I'm left with x plus 4. On the other one, I can pull out a 14, because we know that 14 goes into 56, because we did that up here. So we have 14 and then x plus 4. Now our GCF is x plus 4, and we're left with x and positive 14. Okay, you do have a couple problems like this at the end of your Math Excel work. Some of your problems, and I mentioned this earlier, some of your problems are already at this step, And so you just have to turn it into this. Okay, so some of the problems are halfway done for you, so just a heads up there. Now, I will go ahead and apologize. I know this video is long. It's longer than what our videos normally would be, but I felt like you needed examples, and it's always different with factoring by grouping and factoring out the GCF. Sometimes a class gets it really, really easily, and we can move on really quickly, and everybody thinks it's easy and it's great. Sometimes classes find it more difficult, and it takes more examples. So I do apologize for this being a long video. They will not be this long every time. And it would have been this long or longer if we were doing this in person. So just remember that. I know it's a long video, but it would have been longer in person, most likely. So work through the examples. Use this to do your math Excel work. If you need help or want more examples, come back in the Google Meet. I would be happy to help you, happy to walk through some things, and help you with whatever you need. Have a great rest of the day.